This is our last type of transformation that you have to learn about. They're called dilations, and it gets the term from what happens to your eye when you're exposed, the iris of your eye when you're exposed to a lot of bright light. It gets bigger or smaller. And unlike the other transformations we've learned about, this transformation actually changes the size of the shape. The figure will maintain the same shape, but it can get bigger or smaller. Let me show you how they work in Sketchpad so you can have a really nice picture. So, like rotations, dilations have a center point which doesn't move. And I will typically call that point P. We'll put that point over here. We'll call that P. There's point P. But in addition, unlike a rotation, which you're going to rotate the figure and it's going to turn a certain amount, what's going to happen is this figure that we draw, maybe we'll do a triangle here, it's going to shrink in towards P, or it's going to get bigger and move away from P, and it's going to do so in a very specific fashion. So let me show you what it looks like exactly and what's going on, and then we'll do it by hand and show you how it works by hand. These are kind of tricky. So to dilate something, in addition to having a central point, you need a scale factor, which is a ratio, which this ratio shows you by what factor your figure is going to be getting larger or smaller. So let me show you in Sketchpad how it works. So let's say I'm going to mark this at the center. You don't have to know how to do this in Sketchpad, but it's nice to see what it looks like exactly accurately before you do it on paper. We're going to dilate this figure. And to dilate it, I'm going to say we're going to dilate. And let's say we're going to choose a 2-to-1 ratio. So that's a very straightforward ratio. So this means the figure is going to double in size. It's going to get twice as big. So when we dilate it, we get this larger version of the triangle. Let me show you precisely what's gone on here. What's gone on precisely is if you look at the 3 points that define this triangle, each of them have moved in a straight line farther away from P. Now these lines are guidelines. They're not part of the dilation. They help you understand what's going on. So if I look at this dotted line here, this point here on the original triangle, let me color the original triangle so we can see it. So there's the original triangle I've colored yellow. This point is now twice as far from P as it used to be. So if this was, say, 5 centimeters, now the point has moved and the image point is 10 centimeters away. It's multiplied by 2. It's a 2-to-1 ratio. And that's true for each of the other points. This point has doubled its distance from P, and this point has doubled its distance from P. So when we do this dilation, the triangle, each point doubles its distance from P, and the reason we're doubling it is because we chose a 2-to-1 ratio. We can also make things smaller. Let me delete this here. We'll do another dilation of this triangle, but now let's do a 1-to-2 ratio. Transform, dilate, 1-to-2. And again, remember, you don't have to know how to do this in Sketchpad. So now we see a similar thing has happened, but now each point is half as far as it was from P. And you're always measuring distances from P, both the original point and the image point. It's the distance from P that matters. A very common mistake is to measure the distance between the image and the original point and the image point. We always want to measure back to P. It's like when you're doing rotations. It's the distance from the center that matters the most. So let's see how we do these by hand. We do them in a very similar fashion to what you're seeing here. We're going to use these lines and move things around. But let's do them by hand now. Okay, so let's do a dilation by hand. So let's say I have this point P, which will be my center. And we're going to dilate a triangle. We'll keep it straightforward for our first example. Put this down to there. There's my triangle. And let's say the instructions are dilate the triangle using P as the center and a 5:2 ratio. So it tells you the central point, which is P. So this is the point that remains fixed. And then it gives you the ratio. So this means, this tells me, this is a fraction number, 5:2 this is 5/2 or 2.5. So what this tells me is every point, or perhaps a better way to phrase it is, the image point is 2.5 times as far from P as the original point. So here's how we'll do it. I'm going to label like I've done before, A, B, C, and I need to know how far. Let's make sure I have P clearly here. That's going to be my P. I need to know how far each of these points is from P. So I'll get my ruler. I'll just do some quick measuring here. So PA looks to be about 24 millimeters. I'll make a quick note of that. PA 24 millimeters. PB is, it's hard to tell with this transparent ruler, it looks about 22 millimeters. And then PC is 48, looks like 48 millimeters. Notice I'm not measuring the sides of the triangle. It's P to A, P to B, P to C. What you can do if you want, I'm going to get out a different color here. So I'm going to now draw these lines from P through A, because this is not actually part of the dilation. These are just guidelines. So the points are going to move along this line. They're going to move, in this case, farther. They're going to move away. The image points are going to move away from P and on along these lines. And the way we're going to do it is each of these distances, 24, 22, 48, are going to multiply by 2.5. And then we're going to measure P, that distance, P to that distance, P to those distances, and that will give me the image points that create my dilated figure. So I just need to multiply each of these by 2.5. So if I multiply this by 2.5, let me see what they do. 48, that would be 60 millimeters. So P to A prime will be 60 millimeters. Here, if I multiply this by 2.5, that'd give me 55 millimeters. P to B prime will be 55. And here, if I multiply this by 2.5, that will be 120 millimeters. So P to C prime will be 120 millimeters. And now I just need to measure those and mark where those points are, and I'll do that in red so you can see the different points more clearly. So notice, it's always to P. I'm measuring P to the distance. I'm not measuring between A and A prime. It's not what I'm measuring. It's P to A and then P to A prime. So if I put this down, PA is supposed to be 60 millimeters. That's 6 centimeters. So that's right there. So that's my A prime. This distance is 2.5 times P to A. Remember, P to A prime, P to A, not A to A prime. Here's my line P to B. and that has to be 55 millimeters, 5.5 centimeters. So that's going to be right there. So that's B prime. And then P to C is going to be 120 millimeters. P to C prime rather is going to be 120 millimeters. That's way at 12 centimeters. It's way down here. So that's C prime. And then I connect the dots in the same order. Notice when I connect the dots with the ruler, I put the pen on one, and that holds one end of the ruler in place. Then I pivot the other end, and I connect. So there's my dilated triangle. Each of these points, A prime, B prime, C prime, is 2.5 times as far from P as the original point was. So it's gotten bigger, it's moved away from P. So let's do one by hand where we make things smaller, and then we'll do some examples on graph paper. So let's dilate rectangle ABCD using A as the center and a ratio of 1 to 3. And I'll just freehand a rectangle here. Let's say A is over here. A, B, C, D. So I'm going to dilate this rectangle, A, B, C, D. A is going to be the center, so it's going to be the point that everything moves towards. And the ratio is 1 to 3. So this means 1 to 3. So all the distances from the center, here the center is point A, are multiplied by 1/3. So everything's going to get smaller. Now the rectangle has 4 points that define it, A, B, C, D. Fortunately, A is the center, so it doesn't move at all. Its distance from the center is 0, and we multiply that by 1/3, and we still get 0. So A and A prime are the exact same point. And when you dilate, the central point doesn't move at all. So now I need to move each of the other 3 points 1/3, multiply the distance by 1/3 so they're closer. So I'm going to measure A to B, A to C, A to D, and then we'll multiply those distances by 1/3, and that will give me my image points B prime and C prime and D prime. So let's do some quick measuring here. A to B looks like 71, maybe 72, maybe A to B is 72. So AB is 72. Since I got the ruler here, I'm just going to do it right now. 72 millimeters. 72 times 1/3 is 24. So A to B prime is 24 millimeters. So I'm going to come in here real close. 24 millimeters. It's around there. And that's where B prime will be. So the distance from A to B is 3 times A to B prime. A to B prime is 1/3 of A to B because the scale factor is 1/3. Now we'll do A to C. I'll just leave the ruler down so I don't have to draw the blue lines this time. So that looks like around 84 millimeters maybe. Let me see here. Let me line this up more carefully. 80, I guess it's 83 millimeters. So A to C is 83 millimeters. 83 times 1/3, because the distances have to multiply by 1/3. What is that? I have to do some quick arithmetic here. can't think. 27 2/3 millimeters, or around 28 millimeters. So I'll go 28 millimeters to around there. Oops, I'm doing those image points in red. So there's C prime. And then finally D prime. I measure A to D. That looks like 39. So AD prime is 39 times a third, which is 13 millimeters. So if I go 13 millimeters, that's right there. Notice this is all on the lines connecting A to B, A to C, A to D. So there's D prime. If I connect the dots, I get my dilated rectangle. Everything is 1/3 as long as it was before. A to B prime is 1/3 of A to B, A to C prime is 1/3 of A to C, so on and so forth. And when you dilate, things move in towards the center, or as we saw before, things move away from the center. So now let's see how we do this when we're dealing with coordinates, and it's very much like this example here with the rectangle, how we deal with in coordinates. So let's have a look at that now. So let's say I want to dilate for 1 using, I don't know, 2, 0 as the center, and a 2-to-1 ratio. So here's the center. We're going to have 2-to-1 ratio, and what we're going to do here is very similar to what we did when we were doing rotations in a coordinate context. We're going to plot the points, and then we're going to circle the central point. Start with that. So there's my coordinate grid. 4, 1 is the point I'm going to dilate. Here's 4, 1 right there. 2, 0 is going to be the center. There's 2, 0 right there. And there's my central point. And if you remember, our strategy for rotations is we drew a rectangle and we turn the rectangle. We're going to do a very similar thing here. I'm going to draw a rectangle along the coordinate grid with my center, 2, 0 that I've circled as one corner, and the point I'm going to dilate as the opposite corner, 4, 1. And now what I do instead of turning it is I dilate this rectangle. I take the dimensions of this rectangle. So this is a 1/2 rectangle. So 2/1 ratio means all lengths double. All lengths are going to multiply by 2. So my 1:2 rectangle is going to turn into, my 1/2 rectangle is going to turn into a 2/4 rectangle. But here's the key. It keeps the same corner. So it's going to overlap this rectangle, and they're both going to have this as the corner. I'm just going to make it 2/4 instead of 1/2. So I get something like this. Here's my red pen. So I originally had a 1/2. So instead of 1/2, all lengths are going to double. So I'm going to go 2 here, 2, and I'm going to go 4 here. So I create a 2/4 rectangle. This rectangle is dilated by a factor of 2-to-1, and this is the center. That point stayed fixed. That corner of the red rectangle and the corner of the black rectangle are the same. The answer to the question is, the original point was this point opposite the center, so my image point is still this point opposite the center. So right there is my image point, and my answer is the coordinates of that point, which would be 1, 2, 3, 4, 5, 6, 2. That's how we do dilations in a coordinate context, is we use the rectangle like we use for rotations to help guide and help us understand what's going on, so it's not just a point floating around. One last quick example where we make things smaller. Let's say I want to dilate -1, 4 using, let's say 5, 0 as the center, and a 3:4 ratio. Okay, so here's my center, there's the point I'm going to dilate, here's the ratio. So let's start with the coordinate grid. Here's my axes. -1, 4 is the point I'm going to dilate. -1, 4 is here. 5, 0 is the center. 1, 2, 3, 4, 5, 0 is way over here. I'll circle, and then I'll do the same strategy that I used above. I'll draw this black rectangle along the coordinate grid where these will become opposite corners. So that's my center, it won't move. And all the other points that I'm going to dilate are going to move towards or away from that in a straight line. So there's my rectangle. It's a lot bigger than last time. And this rectangle is 1, 2, 3, 4, 5, 6 by 4. So my scale factor over here is 3:4. So remember, as a fraction, this is 3/4. So all lengths, multiply by 3/4. So I'm going to take the dimensions of this rectangle and multiply both the length and the width by 3/4. So I'll get 3/4 times 4, that's 3. And I'll get 3/4 times 6, and that is, what is that, 9 over 18 over 4, so that's 4.5, 4.5. Is that right? Yes, 9 over 2, yep. Okay, so that means my new rectangle that I'm going to draw, my red one, my dilated rectangle, the lengths, instead of being 6 across and 4 up, it's going to be 4.5 across, 3 up. And remember that it's got to share this corner. This is the center. So that's the point that it stays fixed. So my new rectangle is going to draw in towards that one. Instead of being 4 tall, it's going to be 3 tall. 1, 2, 3. Instead of being 6 across, it's going to be 4.5 across. So I'll go 1, 2, 3, 4.5. That's the halfway point. And I draw my new rectangle. There's the dilated rectangle. This is 3. This is 4.5. And now to answer my question, I need the image of -1, 4. So this -1, 4, which was the opposite corner, the image point is still the opposite corner. So I need the coordinates of this point. And if I look carefully at my grid, I can tell this is 1/2 to the right, because this is 1/2 here from the 4.5. This is 1/2 to the right, and then 1, 2, 3 up. So this image point is 1/2, 3. And that would be the answer to this dilation.